Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. If you really like my videos, please press the like button, share the videos with your friends, subscribe to my channel, and even press the bell button to get the regular updates. In the last video, I have discussed what are the various modes of data transfer such as simplex, half duplex, and then I have discussed about the full duplex communication. In this video, I want to discuss about what is a topology and what are the various topologies are available. Let me discuss about what is a topology, then I will discuss about various topologies. Topology can be defined as the arrangement of elements such as links and nodes of a communication network. If you see any network, we will have the nodes, and between the nodes to have a communication, we will have the communication links. So the topology will talk about the how these network elements are connected. Okay, so we have various topologies based on the communication between the nodes or the arrangement of elements in the network. We have bus topology, we have the ring topology, we have the star topology, mesh topology, and hybrid topology. In this video, we will discuss about all these topologies in detail. First, let me discuss about what is a bus topology. As the name suggests, in the bus topology, we will have a common bus for the communication. Okay, we will have a common link which we will call it as a bus, and the bus at both the sides we will have a terminator. And both the sides of the bus, both the sides of the ends of the bus, we will have a terminator. What is the purpose of this terminator? The purpose of this terminator is once the signal reaches to the terminator, it will make sure that the signal will not bounce back. Okay, so let's take that. To the common bus, I have a device 1 is connected, and device 2 is connected, and then device 3 is connected. Okay. Now, the device 1 wants to communicate with the device 3. Then, usually we need a header, a data, and tail. Am I right or wrong? Now, in the header, what is the things will be there? We will discuss when we discuss about Ethernet, IPv4, IPv6, all these things. But just for the understanding purpose, let's take that we have the source address and we have the destination address and what is the actual data it will send. And coming to the source address and destination address, this address again, it can be a MAC address, it can be an IP address, it can be a port number. Am I right or wrong? These things I will discuss in the coming videos. Just for now, in this video, try to understand one thing, that the source address is to identify the source and destination address is to identify the destination. So let's take the destination 1 want to send the data to destination 3. So source address will be destination 1 to identify the source, and destination address is D3, and we have the data which the device 1 want to transfer the data to device 3. Okay. Now this packet, first it will go to device 2. Am I right? Then device 2 will check what is the destination address. What is the destination address? It is D3. However, this node address is D2. Then it will understand that whatever the data or whatever the packet is coming, it is not belongs to me. Am I right or wrong? So it will neglect it. Okay. Then it will come to the device 3. Then device 3 will check with the destination address. The destination address is matching with the device 3 address. Then it will receive the packet. Are you able to understand? So this is the way the communication will happen. Now what is the problem with this communication, this kind of communication? Let's take that device 1 is communicating with device 3. At the same time, device 3 want to communicate with device 2. Then what will happen? These two packets will collide. Are you able to understand? Collide means collision. Collision will happen. If the collision will happen, both the packets will not able to reach to the destination. Am I right or not? In a traffic, if both the cars are collided, then when these both cars can able to go to destination. They will be there in the road only, and the police people will come, they will take the photos and they will do the things. Am I right or wrong? So if the two packets are collided in the network, they cannot able to reach to the destination. Am I right or wrong? So the collision will happen. One is the problem is collision. And if you see the another problem, or I cannot say that it is a problem, suppose if we have a bandwidth of this link, there will be some bandwidth will be there. This bandwidth is shared with all the devices. If you have more number of devices are connected to this bus which is having a common bandwidth, then it will have a problem. Am I right? Because all the nodes are sharing the common bandwidth. Because all the nodes, if you want to communicate with the other nodes, they have to use this common bus. So that is one problem. And another advantage, let me first talk about the advantages. The advantage is that you can easily connect the new nodes. Okay, suppose if I want to connect the device 4, I can connect here. If I want to connect the device 5, I can connect here. It is very easy, cost efficient solution, because the number of buses are less only here. Are you able to understand? But what is the another problem with this one? Wherever there is an advantage will be there. Obviously we can find some disadvantage. Is it clear? If it is perfect, then why we'll go for other topology? There is a drawback in this one. What is the drawback is that if the bus has some problem, means if the bus has a failure, means the bus has a what you call the disturbance has happened, the bus breakage has happened, then the communication among the nodes will be disturbed and the network will fail. Are you able to understand it or not? If the common bus has some breakage or it can have some damage, then the network will fail. So that is the drawback of the bus topology. However, it is cost efficient topology. Okay, so I hope you have understood how the nodes are connected in the bus topology and how the communication will happen, what are the advantages and what are the disadvantages. Now we will discuss about the next topology, which is a ring topology. In the meantime, I request you to note down those advantages and disadvantages, and even please press the like button. Okay. Now let me discuss about the ring topology. Okay. As the name suggested, the nodes are connected in a ring. Suppose I have a device 1, I have a device 2, I have a device 3, and I have a device 4, and they are connected. Okay. Now remember one thing. The communication, how the communication will happen, the communication will happen in single direction, which is a clockwise direction. Okay. We will not have a anti-clockwise direction. Meaning is that if device 1 want to communicate with device 4, however, you can see that they are adjacent. Am I right or wrong? However, the communication should happen between, first the data should be transferred to device 2, then it will transfer to device 3, then it will transfer to device 4. Meaning is that it should happen in the clockwise direction. In anti-clockwise direction, the communication will not happen. Suppose let's take that device 1 want to transfer the data to device 4. So I have a source address as device 1 address, and device 4 address I will have as a destination address and whatever the data I want to send. Now if you see that the first data will go to the D2. Now D2, once it receives this packet, it will check the destination address. The destination address is not matching with its own address because it is D2 and this is D4. So then it will not receive the packet. Meaning is that it will just check the packet and then it will just forward it. Okay, meaning is that this packet is not mine, so it will just allow it. Okay, then it will come to the device 3. Then device 3 will check whether the destination address is matching with its own address. No, then it will also not receive it, and then it will go to device 4. Now device 4, it will check with this destination address, and the destination address and its own address is matching. So then it can understand that this packet has been transmitted for me. Then it will receive the packet. I hope you have understood how the communication will happen in the ring topology. Okay, what is the disadvantage? The disadvantage is that if there is a link failure, then the entire network will fail. Are you able to understand? Even one device also fail, it will disturb the entire network. Are you able to understand? But however, it is cost efficient solution, and also we can easily configure the new nodes in the network. Okay, so I hope you have understood about the ring topology, how the communication will happen in the ring topology, what are the advantages and what are the disadvantages. Now we will discuss about the star topology. Now let me discuss about the star topology. In the star topology, we will have a central device. We will have the central device. I hope it is clear for you. It is a central device, and that from the central device we will have other devices are connected. Device 1, device 2, then device 3, device 4. Am I right or wrong? Now, if you see that device 1 want to communicate with device 3, then first it will transfer the data to the central device, and from central device it will go to device 3. If any node want to communicate with other node, the data has to pass through from the central device only. Now this central device can be a hub and it can be a switch. It can be a hub, it can be a switch. Now these two are the network devices. Okay, we have various network devices such as router, bridge, all these things. These two are one of them. Okay, we have a hub and we have a switch. Now let me discuss what the hub will do, what the switch will do. Now why it will do, I will discuss when I discuss in terms of the layers, because till now I did not start about the OSI layers. So I should not tell it consists of physical layer, it consists of physical layer and data link layer. I can say, but however you will not understand them. Okay, is it clear? So what I will tell you about the hub is that if you have a hub in the central device, then what will happen? First I will discuss. If you have a hub in the central device, if device 1 want to transfer the data to device 3, then what the hub will do, once it receives the packet, it will broadcast to everyone. What is when we broadcast? Suppose let's take that you have a 4 devices are there. Let's take the device 1, device 2, device 3, device 4 is there. Once the device 1 is transferring the data, you can have a unicast communication, we can have a multicast communication, and we can have a broadcast communication. In unicast communication, what we will do is that device 1 can transfer the data to device 3. So there is a unicast communication. In broadcast, whatever the packet it has sent, it will receive to everyone. If it is received to everyone, obviously the device 3 also will come to know about the packet. Am I right or wrong? It is like a gossip in a large area. Are you able to understand? You can tell some gossip to someone in the ear. That is what the unicast. Or you can WhatsApp someone. Okay, or you can call to someone and tell that information. That is unicast communication. In a WhatsApp group, if you are sending that information, then it is a multicast, because to a certain group of people you are sending the data. A certain group of people, you made it as a one group. For that group you are sending that information. Then we will call it as a multicast communication. If you are sending to everyone, then it is a broadcast. To whoever the contacts are there, you are sending them, then it is a broadcast. Like you are keeping the WhatsApp status. Then everyone can see, whoever the contacts are there, they all can see, then we will call it as a broadcast. I hope you have understood the unicast, broadcast and multicast difference. Okay, so now hub, what it will do? It will do the broadcast. So all the devices will come to know about the packet, and even device 3 will also get the packet. But what is the drawback of the broadcasting? It will increase the network traffic. Am I right or wrong? Because you are supposed to send the data to device 3, but you are sending to everyone. Then the traffic in the network will increase. Okay. Then what about the switch? The switch is little bit costly device as compared to the hub. Okay. So switch is little bit costly as compared to the hub. So what the switch will do is that it has the capability to identify the destination MAC address. Again, I am using the word called MAC address. So don't get confused if you don't know these terminologies. Slowly, I will introduce these terminologies in the coming videos. Okay. So it has the capability to identify the destination address, and then it will send the packet only to the destination address. So it is doing the unicast communication, because device 1 is transferring the data to device 3. Then first it will go to the central hub. Then the central hub will transfer. If it is a switch is there, it will send only to device 3. So then what will happen? Device 4 and device 2 did not receive the packet. Meaning is that it is not doing the broadcast, it is doing the unicast. If it is doing the unicast, the network traffic will not increase as much as in the broadcast. I hope you have understood. Then what is the drawback? If this central device failed, then what will happen? Entire network will fail. Suppose let's take that IRCT website is there. Everyone can book the tickets using the IRCTC website. If the IRCTC website is failed, then we cannot book the tickets in online. Am I right or wrong? So similarly here, if the central device fail, the communication between all the devices will fail and the entire network will collapse. Okay. And what is the advantage? You can easily configure the new devices. Suppose if you want to configure a new device, you can easily connect like this. Okay. Are you able to understand? So I hope you have understood the star topology, how the devices are connected in the star topology, and how the communication will happen if it is a switch, if it is a hub, and what are the drawbacks. Now we will discuss about the next topology, which is a mesh topology. Okay, now let's take that you have a device 1, you have a device 2, you have a device 3, you have a device 4. Okay, now these devices, how they will be connected? Device 1 can be connected to device 2 by using a half duplex communication. Meaning is that both the directions it can communicate. Meaning is that device 1 can transfer the data to device 2. Similarly, device 2 can transfer the data to device 1. Or I can say that it is a bidirectional link or half duplex. Similarly, device 1 can communicate with device 3, and also device 3 can communicate with the device 1. Device 1 can communicate with device 4, and device 4 can also communicate with device 1. Okay. So now if you see that, what is happening? If you see the bus topology, ring topology, star topology, there is only one communication link between devices. Suppose device 1 want to communicate with device 2, there is only one link is available. If that link is problem, then the communication is damaging. Am I right or wrong? Or the communication between the device is failed. So to have the reliable communication, people have gone for the bus topology. Okay, even I forgot to have a communication link between device 2 and device 3, and all the links are half duplex, or you can consider it as a full duplex. I want to tell they are bidirectional links. Okay, now if you have a mesh topology, one is the advantage is that reliable communication. You can ask me, sir, how it is reliable communication? Let's take that device 1 want to transfer the data to device 4. Is it clear? Now, how many ways it can transfer the data? If you see that the data can be transferred using this link between device 1 and device 4. Am I right? Even it can send the data to device 2, and then device 2 can transfer the data to device 4. This is second way. And third way, I can send the device data to device 3, and device 3 can do it. Now, what is the advantage? If this link is failed at some point, the link between device 1 and device 4 is failed, still you can communicate the data between the device 1 and device 4 but various other links. Okay, so that's why the mesh topologies are reliable. But what is the problem with this one? If you see that from device 1 you have 3 links. If you see that if you have n devices are there, from each device 1, you will have n minus 1 links. If you see that device 1 is there, totally how many devices are there? 4 devices are there. Now how many links are there, or how many outgoing links are there from device 1? This is one link, this is second link, and this is third link. So n minus 1 links are there. And totally how many links are there? If it is a half duplex or full duplex, I want to say if it is a bidirectional, you will have nc2 links, which is nothing but n into n minus 1 by 2. Okay, these many links are there. So how many? If you have n is equal to 4 into 3 by 2, which is nothing but 6 links will be there in the, if you have 4 devices. So the number of links are more. However, the advantage is reliable, but it is costly solution. Okay, so if one link fails also, there is no problem. Still the communication can happen between the devices. So I hope you have understood about the mesh topology and how the communication will happen in the mesh topology, what is its advantages and what is its disadvantages. Now let me discuss about the last topology, which is a hybrid topology. The hybrid topology, I can call it as a combination of these topologies, any of these topologies. Okay, so let me take it as hybrid topology. As the name suggests that it is a hybrid. Okay, meaning is that you can have a bus topology, means combination of these one. Let's take that I have a bus topology. Device 1 is there, device 2 is there, then I have device 3. Then you can ask me, sir, always bus topology will have 3 devices. No, just for your understanding, I am taking 3 devices and you have a common bus. Okay, now we can have a star topology like this. I have a device 4, device 5, device 6, device 7 is there. And then I can have some other topology, like a mesh topology or thing. So if you see that we have a bus topology, the bus topology is connected with some star topology, and some star topology we have connected to some other topology. This kind of topology, we'll call it as a hybrid topology. In the real-time networks, whenever we are going for the connecting the nodes or devices in some university or some real time, let's take that, then we will have this hybrid topology, because some ring topology will connect. From the ring topology we can go for a star topology, like that people can go for in the real time. So there we will use the terminology called as hybrid topology. I hope you have understood what is a topology and what are the various types of topologies. If you still have any doubts related to this video, feel free to ask me in the comment section. I will try to clear your doubts in less than 24 hours. If you feel shy to ask the doubts in the comment section, you can send an email to Parnika Tutorials, which is the YouTube channel name, @gmail.com. Okay? Even if you send the email, I will try to clear your doubts in less than 24 hours. I hope you have understood all the concepts. If you really like the video, please press the like button, share the videos with your friends, and subscribe to my channel for regular updates. Thank you for watching my video. Have a nice day.